Welcome to the acid-base unit. We are going to start off by taking a look at some definitions and getting an idea of what it means to be an acid or a base. So first, we're going to take a look at what it means to be an acid. Okay, basically, an acid is an aqueous solution containing the H plus ion. Now, we're going to call this H plus ion a number of different things. You may hear me refer to it as a proton. You may also hear me refer to it as a hydronium ion. And what a hydronium ion is something that looks like this. It is H3O plus. Or a proton just looks like this, H plus. So you may hear me say a hydrogen ion, a proton, or a hydronium ion. All of those things are the same thing. A base is an aqueous solution that contains a hydroxide ion. Okay, these are sometimes referred to as alkaline solutions, and alkaline is just a fancy science way to say something is a base. Okay, and it makes it to where we don't have to say something is basic, because a lot of times basic sounds like something is simple. So this is more just saying that this is alkaline. It is a base. So we want to take a look at a few different people in terms of their theories and see what some different scientists said about being an acid or a base. And the first person that we're going to take a look at is Arrhenius. All right, Arrhenius um, had the most simple idea of what it means to be an acid or a base. Basically, what Arrhenius said is that an acid is any substance that forms the hydronium ion in water. So uh, if we have a dissociation equation like this with nitric acid here, and nitric acid is going to dissociate, and when it does, I end up with a proton or a hydrogen ion and a nitrate ion. Okay, so here's my H plus. Now you may be thinking to yourself, I thought Arrhenius said it makes a hydronium ion. Well, let's think about this for a moment. If we have an H2O molecule, and it looks like this. Here goes our H2O. Here's my Lewis dot structure. Okay, so I've got these two unshared pair, or this unshared pair here, and this unshared pair here. What's going to happen with that H plus ion is the H plus ion is going to swim over and it's going to find this unshared pair and it's going to stick itself to that, and that's what gives us the hydronium ion, which looks like this, H3O plus. So that's why you have protons or hydronium ions. This proton's never really going to exist by itself. It's always going to make the hydronium ion, but for simplicity, a lot of times when we break it down, we're just going to break it down as H plus. Okay, so that's what this is showing here is that nitric acid actually reacts with water to form a hydronium ion plus a nitrate ion. Okay, Arrhenius also said that a base is a substance that forms a hydroxide ion in water. And this can happen a number of different ways. As y'all know, my videos they are messing up right now, so give me a moment to get rid of this. While this is happening, I'm going to keep going. Basically, as I said a moment ago, Arrhenius says that a base is a substance that forms a hydroxide ion in water. All right, let's see here. Sorry for that delay, folks. Either way, a base is a substance that forms a hydroxide ion in water. So as you can tell, sodium hydroxide is going to dissociate into a sodium ion and a hydroxide ion. So that gets us into what Bronsted-Lowry said about acids and bases. In fact, we're going to be talking about Bronsted-Lowry most often when we refer to acids and bases and their definition. Okay, so what Bronsted-Lowry said is he said that an acid is a substance that donates a proton. All right, so when we take a look at this situation, I have two reactants. I have HCl and water. And so I'm going to look at my products and I'm going to see what happened to my H. Well, I see here I have an H that's part of HCl, and over here that H is gone. The H that was here has gone from here over to here to make a hydronium ion, so H3O plus. So that's going to make HCl my acid. Okay. Um, Bronsted-Lowry also said that a base is a substance that accepts a proton. So it's going to accept a proton. And so that would make H2O in this case the base, because the hydrogen that was donated from HCl is going to be accepted by H2O. So we have an acid-base pair here. So that gets us into Lewis. And what Lewis said uh, was, well, Lewis kind of had a tricky definition of acids and bases. And to be real honest, we're not going to talk a whole lot about the Lewis definition, but it is important for you to at least know it. What Lewis said is that an acid is a substance that accepts an electron pair, and a base is a substance that donates an electron pair. So, like I said, just be aware of the definition of the Lewis theory of acids and bases. We're mainly going to focus on the Arrhenius definition and the Bronsted-Lowry definition, but that will at least get you an idea as to what some of these scientists thought acids and bases were. Thanks.